Uh, well, at least it's all, I'm learning it all now, figuring it all out. Okay. Good. Everybody's back. Terrific. Cool. All right. So welcome back. Here is our problem. It is a, like we said, it's a linear correlation problem. And then we have two parts. The first is the hypothesis test, and then the second part is this prediction part. If a court income is 1,000, predict the justice salary. So first off, our hypothesis test. So H naught is that rho equals 0. H1 is rho is not equal to 0. Step 2, find our critical value. So you're going to bust out your PPMC table. And, we've talked about degrees of freedom. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 pairs of data. So my degrees of freedom is going to be 9 minus 2, because remember that's two variables. So it's 7. And then there's no alpha listed. So if there's no alpha listed, then our alpha, default alpha is 0.05. That's our general guideline for alpha. And then if you forget the degrees of freedom, you guys look up on your table, you'll see it says it right here, degrees of freedom equals n minus 2. That helps you out a little bit in case you've forgotten or you can't remember which one is n minus 2. It tells you right there. So you can just look on the table and it'll tell you. So 7, alpha is 0.05, 0.666. That's your that is your critical value. So we're going to put it in, draw our line, put it in, shade to the right, and then put in the negative 0.666, and shade to the left. And those are our rejection regions, our guilty regions. And then we're going to bust out our calculator and say, okay, let me go ahead and put my data, stat edit, put my data into list 1. My x is in list 1, my y is into list 2. And then double check and make sure your data is correct, because it's really easy to mistype it. And then make sure you have them all. You don't have anything extra. Because you have something extra, it's going to give you an error also. Here, I'll show you. If I accidentally had something left in there, left over, then when I go to do stat, test, lin-reg t-test, L1, L2, frequency 1, it's going to give me an error, dimension mismatch. That's because they don't match up. So I have to clear, stat, edit, and then go back in and say, okay, which one is wrong? These all look like they're right. Oh, there's an extra one there. So then you have to delete that one. You hit delete, and that one will go away. Stat, test, lin-reg t-test, and then calculate. That will give me, oh, there's my A and my B. I'm going to write them down, 27.70, write that down. My B is 0.03728, write that down. And then keep on toggling down, arrowing down, and then there's my R. Now my R squared, my R. R squared, incidentally, is roughly the percent of points that match up pretty well with the line. So about 75% of the points go along with the line fairly well. My R is 0.864. So I'm going to put that in, 0.864, that's my R, and throw it in here. It goes in right here. So it's totally in the rejection region, which means I reject H naught, which means I do have enough evidence to say there's a correlation between court income and justice salary. So that's your hypothesis test. So even on the exam, when I say, give me your answer to step 3, you still have to do steps 4 and 5. I just need you to, that's your check to see if you got it right kind of later on, to kind of get a sense of how you're doing on the exam when you log out, is then putting that one in there, and we can kind of see where you're at, and also I can kind of see where you're at as well. Part 2 is the court income is 1,000. Court income predicts the justice salary. So court income, is that my X or my Y? That is my X. So when X is 1,000, court income, my X is 1,000, predict my Y. So I'm going to put in 1,000 for my X. So there's my correlation, Y equals A plus BX. So I grab it from here. A is 27.70. B is 0.0328. Because I rejected H naught, then I can use this. If I didn't reject H naught, then I would just use the average Y. I'd find my Y bar from StatCalc Q-bar stats. Okay, so here I'm going to put in 1,000 for X, and I end up getting Y is 54.98 or Y is 55. Good?
Professor Young?
Mm-hmm.
I think that number is wrong. At least in my group, we got 65 for our number.
You got 65? Oh, it is 65. Sorry. Oops. Yeah, it's because I'm trying to add in my head, which is apparently troublesome. 65. Thank you so much. You guys are great. Perfect. Much better. Okay, good. Cool. Nice. I think I solved the thing of the bomber. I suspect the bomber is somebody who dropped the class because they weren't doing well, and then they were all pissy because you know, they don't know what they're doing and had to drop the class. That's my suspicion. All right. Okay. So here we go. Here are the common mistakes from exam 3. The first one is proportion. People would do a proportion when there's a mean problem, or they do a mean when there's a proportion problem, right? So remember, if it's a mean problem, it will literally say mean or average in there, always. Yes, it could be random people. I've locked it, so now people get put into a waiting room before they can come in. No one can come in unless I let them in from the waiting room, which is, yay, I'm figuring things out. It's taking me a while. I'm just a little slow with this. All right. So mean, you know, so if it says mean or average, it's a mean. If it doesn't, and it's from you know, chapter 7, 8, 9, then it's probably a proportion, right? The other issue they had was realizing there's a difference between X and X bar. They'd start grabbing the X bar and they'd try to make it into proportion somehow, which is just craziness. X bar is your mean. X is your number of successes. They are not the same thing. Okay, the other thing that people messed up on in the exam was if it was a proportion, if it's a proportion, I will give you either X or P, right? So P would be the percentage. X is the number of successes, how many people. They're not the same thing. So here, if I say 3 students ate cheese out of 9, 3 is not your percent, it's 3 students. This is your X. So then to find the percentage, you do percentage equals X over N, like you think you would, right? 3 over 9. But if I give you 14% of students ate cheese out of 9, this is not your X. This is your percentage, right? This doesn't mean 14 students. This means 14%. So it's already the percent. So don't go putting 0.14 over 9. That's totally crazy. You're going to get something insane. So it's not that. So if you want to find X from here, I'm giving you P, then you use this formula here, X equals N times P. Okay. So you're given either P or X, but don't confuse them. They're different. How do you know? P has a percent attached to it. That's how you know. Okay. Or it's a decimal, right? It could be written as 0.14 maybe. The other thing is a lot of times on the critical value, they did the wrong critical value. So either they it was a proportion and they used a T table, or it was a mean and they used a Z table. So remember, mean Mr. T means use the T table. It's easy peasy. If it's a proportion, P, use a Z table. They lost 2 points. You lost 2 points every time you did that. Should have been 3 points on the final. It'd be more. It will be more. So heads up on that one. If you got the right table but just picked the wrong column or the wrong number, you only lost 0.5%. So if under your critical values you had a -1/2, it's because you had the right table, just the wrong number. The other thing was, make sure you give me the whole test, all 5 steps. Even though I only asked you to input step 3, I still want you to do the whole thing. I'm just having you, 3 is an easy one to have you spot check, right? It doesn't, 5 is a lot harder to match. It's harder to match enough evidence, blah, 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 blah. It's a lot to type in, and you have to match it exactly, if you have spaces or whatever. And plus, it only has a limit to how many characters you can type in. So step 5 just is a lot harder to have you type in. 3 is an easy, good kind of check for you to see if you have it right or not. So that's why I'm having you type in your answer to step 3. And same thing with confidence interval. Do the whole confidence interval, the blank, comma, blank, right? X bar minus E and X bar plus E, or whatever it is. Not just your margin of error E. Give me the confidence interval also. I'm only having you type in the margin of error E because what you answer for this is going to vary so wildly. People are going to put, this is less than X, or mu is less than that, and then how do you even write mu? Do they write it mu? Do they write it u? So there's so many different ways of writing that. It's just easier to type in the number, margin of error E. So that's why I'm just having you input that part, so you can kind of check and see if you got it right, sort of get a sense of whether you have things right from that. Okay, so again, even though I'm only going to have you type in one thing as an answer, give me the whole test. Give me all 5 steps. Give me the whole confidence interval, all that stuff. And show me all your work, because I'm going to want that. All right. Here is a couple of problems. Let's go ahead and just review a few of them. So the first one is this one. 42% of college students work part-time. You randomly select 4 students. What's probably that all of them work part-time? So you could use what you know from binomial to solve this. You could totally do that one. And if you're more comfortable with that, then that's totally okay. The beauty of it is you don't even need binomial, because anytime you have all or none, then there's no confusion. It means that it's the probability of work part-time, yes, and yes, all of them, and yes, and yes. So it's all of them are yeses. So you have to worry about the order of which one, was it yes, no, yes, yes, or yes, yes, no, yes, or was it, you don't have to worry about it because they're all the same. And it's really easy if they're all the same. Yes and yes, and yes and yes, just means they all are. What's probably the first one was? What's probably the first guy said work part-time? 42%. Great. 0.42. Perfect. Thanks. What's probably the second person said yes? 0.42. Same thing, right? What's probably the next person said yes? 0.42. And the last person, the fourth person, said yes? 0.42. Because remember, we're talking about students. There's a lot of them. Not, I'm only picking 4, but out of all of the students. Now, I want this to be yes and this one, and this one, and this one. Everyone private chat to me. And we do what? Private chat it. Private chat it. One person. And we blank. Type it in. And we and we multiply. So you're going to multiply these. This is good review. Right, and you'll end up getting something like 0.03 something. I don't remember what. 034, let's say, something like that. 032. 031, I think it was actually. Oh, no. No. Oh, I don't think I can undo that. Oh. Okay, good. Phew. Okay. So, so is this likely or unlikely? And explain. So unlikely, what's our guideline for unlikely again? If it is, something's unlikely if it is 5% or less? Exactly. 5% or less. Is 0.03 5% or less? Totally, it's 3%. So it's unlikely because it's less than 5%. Make sense? What's probably none of them works part-time? What's the none of them? Did I just lose somebody? No, I can't gain anybody because. Okay, no worries. So none of them works part-time. So what's the probability that one person, I pick somebody and they don't work part-time? They don't work. So just one of them doesn't. What's probably I pick a person and they do not work part-time? Yeah, 1 minus 42% for one person. So that's probably the first person doesn't. But I need the first person not to. So what I need is the probability of no, 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 no. 4 no's in a row. All of them say no. So that's going to be, yep. So again, it's going to be no, and no, and no, and no. This is 1 no. I need 4 no's. And we multiply, we multiply. So you're going to end up with this here. Good? All right. Next. Maybe. Oh, interesting. Oh, we didn't get to that one. Okay, so how about this one? What do you guys think about this one? Do you guys want to go into your rooms for just like a minute, 2 minutes? Yes.
Before we go into the room, can you go back to the slide before this?
Yes. I'll go ahead and I'll type this better. I should be typing this better. Whoops. 0.42 times 0.42 times 0.42 times 0.42, which equals 0.031. There. Much better.
Thanks.
You're welcome. There we go. Let's that out. Okay. Oops, but that's not right. That's totally wrong. All right, so here's this problem. And I want to take a picture of this one. I'm going to give you 2 of them. Can I give you this one? Does everyone have a picture of it? Or just write down 4 digits followed by 2 letters. 4 digits, 2 letters. How many letters in the alphabet? Anybody? 26. 26 letters in the alphabet. Don't forget that. How many digits? 0 through 9. There's 10 digits. Don't forget 0. 0 the hero. And I'll leave this one up also. So I'm going to open up the breakout rooms for you guys to jump in there. And I'll give you guys, I don't know, 5 minutes. Let me go and stop it. So what do you guys think? Is it better to have this shorter 15-second closing time once I close the breakout rooms? Is that better? It's probably better, huh?
Yeah.
Okay.
Yeah.
Good. Good, good, good. All right, so let's take a look at the first one. Did I not get that far? Oh, here we go. All right, so the first one, sorry, I didn't do that one yet. My bad. That's this one here. All right, so here we have, let's see, we're making 6 decisions. Right? 1, 2, 3, 4, 5, 6 decisions. So for this first decision, how many choices do I have for the first decision? Choosing a digit. 10. Great. How many for the next decision? Also 10. Next one, also 10. Next digit, also 10. The next digit, A, a letter, I have 26 choices. And for the last letter, 26 choices, because you can reuse. And again, we're going to, you multiply you multiply the number of choices for each decision. So you should end up with that large number, which I have no idea what that is. It's 26 squared. 26 times 26, 676 with a bunch of zeros. So that's 6, 7, 6, and then 4 zeros, 1, 2, 3, 4. So 6,760,000. Great. Next, so that one's not too hard, right? This is the, so how do you know that it's not one of those other harder ones? Because you can reuse things. Once you can reuse things, then it's not a permutation or combination. It's just a regular up, straight up, how many choices, how many decisions, and how many choices for each decision. So here I'm making 6 decisions. I have 10 choices for the first, 10 for the second, and so forth. This one, you have your totals, so hopefully you put your totals in there. And then broccoli, 51 people like broccoli, so 15 out of 100. Man or child, let's see, so I have 38 men, I have 22 children, there's no overlap, so 38 plus 22, that ends up being 60 out of 100. They probably like they're a child or they like broccoli, so that's this purple stuff. Child, 22, broccoli, 51, so I add those, but see this 10 here? It's included in both the 51 total and in the 22 total. It's getting double counted. So since it's getting double counted, you have to subtract off one of them, so it only gets counted once. So that ends up being 63 out of 100. And then dislikes broccoli and is a man. Now you might say, and I multiply. True. However, the beauty of it is, if it's a table, you don't even have to do that. Because you need to have broccoli, men. Men who like broccoli, there are 17 men who like broccoli, who are men and they like broccoli, 17 out of 100. If you multiplied, you'd have to do men who like, probably they like broccoli, so 51 out of 100 multiplied by probably they're a man given they like broccoli, so it'd be 17 out of 51. So it'd be 17 over 51 times 51 over 100. The 51s would cancel out and you get 17 over 100. That's a little more complicated, but just as a reminder. Okay, good. Do you guys want to see that? I can show you that if you want. Why is it not 21 out of 100? Which one not 21 out of 100? The last one?
I think they're talking about the last one.
Because it's, no, dislikes broccoli. It is. Because Ms. Young can't read, that's why.
Professor Young, are we going to get to try one like this?
What do you mean? Didn't you just try it right now?
No.
This was the problem I posted up on the board and said, do this one also before you go.
Move into my breakout room then.
Sorry. Yes.
Professor Young, can you explain the last part again?
Yes. So they dislike broccoli and they're a man. So they're a man who dislikes broccoli. That's this group right here, 21.
Oh, okay. Yeah.
Yeah.
Just dislikes, okay.
Yeah. I didn't read it correctly.
Yes.
Right. So Angel, you can read this one. Take a picture of it and then work on it. Don't look at the answers and just take a picture of it now and work on it on your own. I'll leave that for like 10 seconds.
Got it. Thank you.
Okay, sounds good. Cool. Next one is, I did that already, is I wanted you guys to get a little bit of a feel again for this. We haven't done this in a long time, right? So this whole group frequency distribution using 7 classes. So tell you what, I'm going to go ahead and just do it with you because I think it's important. Hold on, let me get there. Oop, lost another one. Okay. So, I'll show it to you guys, it's fine. So first the range. There's no mid in range, so we're not doing the whole averaging and dividing stuff. There's no mid, so it's just going to be you take the upper and the lower and you subtract them. So the highest is 68, the lowest is 8. We're going to subtract them, we get 60. Now, then it says make a group frequency distribution using 7 classes for the data, including relative and cumulative frequency. So here, well, let's see, 7 classes. Do I have, is this 25 or more? Yes. So I'm going to do in groups of 5s or 10s. Should be 5s or 10s. What do you think? 7 classes. My range is 60, so I can do them in 10s. So I'm going to go 10s. So I'm going to take my minimum, 8, and find the 10 that is less than 8. So what's the 10 that's less than 8? 0. Does that make sense? Perfect. Nice. So I'm going to do 0, and then the next group, remember when you do all your classes, you go down. So 0, and then 10, 20, 30, 40, 50, 60. You do all the first ones first, the lower class limits. And then you back up and say, well, what comes before 10? 9. What comes before 20? 19. What comes before 30? 29. And then you can see, oh, these all go up by 10 as well, so I can just do the rest of them, 39, 49, 59, 69, done. Okay, and then add them all up. All right, so we should add them all up. Let's see. What do we got going on here? We've got, I might regret this. Okay, so we've got, I'm going to regret this. Let's just pretend like I did them and the data doesn't match. That's okay. So say there's 2 of them, 5 of those. You guys can do this later on your own. 6 of those, 4 of those, 1 of those, 3 of those, 4 of those, and altogether we have 25. Just say. I didn't count them, but let's not waste time counting. Is it possible to use long list in ascending order? Yes, I'll give them to you in ascending order so you don't mess them up as you'll waste time on that, because that's not what I want you spending your time on. Good. So then your relative frequency is going to be how it relates to the total, right? It's the ratio. So 2 of them out of 25. 2 over 25 as a decimal, 0.08. The next one, 5 out of 25 as a decimal, 0.20. This one would be 0.24, 0.16. So these are our frequencies, the straight up numbers, the whole numbers. The relative frequencies are the fraction or decimal equivalents of those, right? What percentage of the whole are they? And then cumulative is, remember how you accumulate them. So in other words, 2, how many are in this group or more? 2. How many are in this group or more? Well, 5 plus 2, 7. This group or more? 6 plus what came before, 6 plus 7, 13. So that's the cumulative, is when you accumulate things, you add things in. So I just wanted you guys to get a quick reminder about those. You guys, when you take a picture, I can scroll if you want to take a picture, and I can scroll back down if you want. Yes, no? Or it's all going to be on the board with PDF as well. So you can just look there. But here's the, if you want to take a picture of it, here it is. I'll leave you with that for like 5 seconds. 5, 4, 3, 2, 1. And then we should look at this one. So everybody take a picture of this. I'm going to put you in a room for 4 minutes and let you work on this one. So 4 minutes. Take a picture and go. Vanessa, are you not here? You're not here, huh? Oh, I gotta stop recording this.
Do you want us to just leave it as fractions
Yes.
for the exam, Professor Young?
Yes, fractions are great.
Okay.
So just leave it as fractions. So what you'll see,
We don't have to write down all in the decimal form.
right, I do not need it as decimal form. And in fact, I prefer it as fraction form. Probabilities I prefer as fraction form, generally speaking. If I give it to you as a fraction, though, as a decimal, then you have to use a decimal because you can't make that into a fraction. That'd be a pain in the butt. So two red, 4 blue, 5 green. So 11 total. So your first probability, remember, it's you draw your branches, and the end of your branches are your options. R should be at the end, B should be at the end, G should be at the end. Your probabilities you write along the way on the branch. So 2 out of 11 is along the way to get to R. That's how much it costs to get to R, right? 4 elevenths, that's how much, that's your probability of getting to B. Green, 5 elevenths, probably of getting there. Now, if I got to the red, say I'm standing right here, now I only have 11 marbles, and only one of them is red. So my next, I could go, from here I could go red, blue, or green, but I only have 1 out of 10 chance of red because I only have 1 red left. 4 out of 10 blue, 5 out of 10 green. If I'm here, now I've taken a blue and not kept it. So now I only have 10 marbles, but now I only have 3 blue because I took a blue one. So now I have still have 2 out of 10 red, 3 out of 10 blue, 5 out of 10 green. And then down at the bottom here, if I took a green one and kept it, then I'd still have 2 out of 10 red, 4 out of 10 blue, but now I only have 4 out of 10 green. So that's how your table should look. That's going to be worth a fair amount of points on the exam because there's so much stuff going in there. I can only test a handful of things in probability. So that one is, going to be one of the more important things. Now, the first draw is either green or red. So green or red, there's 5 11ths there, 2 11ths there. If you add them, you get 7 11ths, right? 2 chances here, 5 chances there, out of 11, 7 11ths. Blue then red means I go along this blue path, and then I cut up along the R path, the red path. So I go along this path, and remember you multiply as you go along the path when you go along these trees. So to get there, you'd go 4 11ths times 2 tenths. And to multiply fractions again, you multiply the numerators and you multiply the denominators. If you screw that up, then at least if you've done this, then you'll get almost all your credit. And the other thing you can do is you can also do this in your calculator if you want. You can do the fractions here. If you don't like multiplying fractions, that's fine. Just multiply them as decimals and you'll get a decimal answer, and that's okay too. But show your work at this part here because that's where most of your credit is going to come from. There's one more I want to bring up before we go, which is not this one, which is this one. Weights of rats have a mean of 115 grams and standard deviation of 16 grams. What's probably a rat weighs less than 112? This is a regular, ordinary normal CDF problem from chapter 6. You're talking about probability that a rat, one rat. Then if I ask you if you randomly select 36 rats, what's the probability that their mean weight is less than 112? That's different because you're talking about someone pointed out that this mean is not the same as this mean. We're talking about the mean weight of the sample. And we're talking about 36 rats. Now we have an N. If you have a sample size N, then it's no longer about one rat, it's about 36 rats and their mean. When you have a sample size N, that's central limit theorem. So you're going to use sigma x bar. Right, so in this case, you have an N. Oops, it's not taking it. You have an N, so you're going to use sigma x bar instead, which is the old sigma over square root of N. And you use that to find your, because this one up here, you're going to do the steps of, number one, you're going to find the z-score. Number two, draw a picture and shade. And then number three, you're going to use normal CDF to find the area, or the area is the same thing as probability. So over here, this one here, you'd add this extra step in here, and then you would use this number for your z-score for the one below. If that makes any sense. Okay, that's good. The only other thing I would tell you guys is you probably really want to go through this survey of what kind of problem this is. I'm going to go through this. Actually, I'm going to do this on the review. I'm going to do more what kind of problem is this, because I think that's really important. So we'll do that next Tuesday at the review if you guys want to come. If not, then you can watch the video of it also. Or you want that up there, Jay? Sorry, I took it away. You can use those notes, like I said, from the exam study guides. There's a whole bunch of those. What kind of problem is it? Down at the very bottom, and the solutions are at the very, very bottom. So you want to take a look at those. All right, that is it. Have a great weekend.